Alright guys, we have another video here on hypothesis testing. This is just going to walk us through a couple examples so that we can get to know it better. So here's our first example. A 1996 report from the U.S. Consumer Product Safety Commission claimed that at least 90% of all American homes have at least one smoke detector. So 90% of all American homes have at least one smoke detector. The city's fire department has been running a public safety campaign about smoke detectors, consisting of posters, billboards, and ads on the radio and TV. The city wonders if this effort has raised the local level above the 90% national rate. So we're wondering if this campaign has worked and raised the percent that have smoke detectors to above 90%. Building inspectors visit 400 randomly selected homes and find that 376 have smoke detectors. Is this evidence that the local rate is higher than the national rate? So is the local rate higher than the national rate? And that the ads were working. So we're going to determine the null and alternative hypothesis, which we label as HO and HA, this being your alternative. The alternative is the one that we want to show, and so I usually start there. So in this case, we are trying to show that the local rate, so the rate in this town where they selected their sample, is higher than the national rate. So we want to show that the local rate is higher than the national rate. So we're showing higher than the national rate. And the national rate is 90%. So we want to show the P in this town is higher than 0.90. But for now, we have to assume that it's not and that it's still 0.90. It's the same as the national rate. So this is what we assume to be true. And then our result will either say, okay, yes, we can't deny that, or we can say that's not true and we'll accept this. So this we assume is true until we can prove false. If you read the book to help you, the book uses a great analogy about being guilty versus being innocent and like being put on trial. So what we're doing is we're putting this HO on trial. For now, we assume it's innocent until we can prove it's guilty, and we reject it. Okay, so then we're gonna label everything that we have. Well, we have our P is 0.90, and we have our Q then is 0.10, 1 minus 0.90. And then we also need a sample so that we can create our curve. So in this example, they said that the building inspectors visit 400 randomly selected homes. So that is our sample. This other thing we have is the 376 out of the 400. So that 376 out of 400, since it pertains to the sample, that's the proportion of the sample with fire smoke detectors. So we call that the p hat. We don't really use it just yet, but I'll write it down for now. Our sample proportion, p hat, is 376 out of 400, which we can then type in our calculator. .94. So the question is that significantly high or not? Is that normal or for sample variation, or is it significantly high? So before we can deal with that, we need to make sure we can model it normally, and so we have to do all of our checks on our sample. So is it randomly selected? Well, yes, it says so. Is it big enough for normal? Let's check that now. That's 400 times 0.10 is 40, and that is bigger than 10. And 400 times 0.90 is 360, which is bigger than 10. So it is big enough. Independent. One home does not affect another. Homes having smoke detectors don't affect others. And then just to double check for that independence for a small enough sample compared to the population, 400 is less than 10% of all homes in this town, in the city, and we have to assume this is true. All right, so then we can model it normally. We need to find the standard deviation for that. So it says draw a diagram. I'm gonna draw it right here. We know that in the middle goes our P. So sample should show 90% have smoke detectors, but there is gonna be some sort of variation. So we calculate that variation as the square root of PQ over N. So the square root of P times Q divided by N, 0.015. So there is some variation. And we want to see, is it possible to get our sample given this variation? That's right. And then it says, what is the z-score for our sample? So here's our sample. It says 94%. So we're out here. And since we're looking for having 94% or higher, we're going to go greater than. The higher comes from our HA, what we're trying to show. So we find the z-score by saying, here's our sample. How far away is it from the center? And how many standard deviations is that? So 0.04 divided by 0.015, 2.666666666666. Okay, and then to find our p-value, how do we go from a z-score to a probability? What is the area of the shaded region? Z-score to probability is normal CDF. What's the probability that we could get the sample that we have if that 0.90 is true for the city? So let's find out. .0038, which is 0.38%. So it's basically impossible. There's less than a 1% chance that we could get our sample if that HO is true. But we got our sample. So that HO is not true. So we're gonna reject HO. And you can kind of remember that phrase. If the p-value is low, reject the HO. So we reject HO, and so our conclusion has three parts. The first part is, since our p-value is low, and what we use to determine if it's low is usually something called a significance level, and it's usually 5%. So we say if it's below 5%. Since our p-value is low, we reject HO. That's the second part. And the third part is to interpret it. So we have evidence to show a higher percent have smoke detectors. So the ad campaign is probably working. How do you spell detectors? detectors. Got a little crazy there with my X. Okay, so have smoke detectors, so the campaign is probably working. All right, and that is an example of a hypothesis test. We're gonna do one more, and then that will be the end of our examples. So let's try another one here. A report was released claiming that at least 15% of trees, Tahoe trees, were infested with beetles, and the forest was suffering. An alert was released to raise money to hire pest control to help the situation and save the forests. As an avid, rich environmentalist, you want to support it by donating $1 million to the pest control, but you're not sure if the infestation is really that severe. A team was sent out and tested 1,500 pine trees for traces of the bark beetle infestation. It was found that 140 of the trees showed such traces. Is this enough to show that their estimates of the severity of the infestation were wrong, that it was too high, and you should not support them? So these guys are claiming that at least 15% of the trees have beetles. And we want to show, hey dude, they're going a little crazy. It's not that bad. So we want to show that it's actually not that many, it's less than that. So what we want to show is that it's less than 15%. What they're claiming is that it's greater than or equal to 15%, at least 15%. You can write it like this as long as you have the equal sign. Okay, and so they say that they go out, a team was sent out to test 1,500 trees. And our, oops, I lost my P. Our P is 15, which means our Q is 0.85. Okay, and so they want to see what's our sample, how does it compare to the distribution if this is true. So our sample was 140 out of the 1,500, which were infested. Sometimes that will be given as a percent already, but right now it's not given as a percent. Oops, 140 divided by 1,500, 0.093. Okay, again, we check it's modeled normally. Random selection. We have to assume it. It doesn't say big enough for normal. I mean, 1,500's big, so it probably is, but let's check. What is that? 225, totally big enough. So we are definitely big enough for normal. We have to assume that there are, that 1,500 is less than 10% of all trees in the area. We have to assume that. I would say that's probably true. If it's a forest, it's probably got more than, I don't know, 15,000 trees, maybe? I don't know. Independent. One tree being infested does not affect another. Okay. So now that we can make a normal curve, we'll make one over here. We know that P goes in the middle. We're assuming that it's 15% that are infested, but it could vary by our standard deviation, PQ over N, square rooted. Take our calculator, square root of P, Q over N, 0.0092. Very small. I'm not gonna draw my I'm not going to draw it in here. However, I'm going to find my z-score for 0.093. 0.15 divided by my standard deviation. How many standard deviations away from the mean am I? I am a lot of standard deviations away from the mean, negative 6.196. So I'm like all the way down there. 1, 2, 3, 4, 5, yeah, about there. Okay, and so what is the p-value? Well, since we have a less than, and we're going to the less than side, I'm gonna normal CDF using negative 999. And I get 2.907, E negative 10, so that's 2.907 times 10 to the negative 10th, a very, very tiny, 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 tiny number. So because of that, again, I'm going to reject HO. If it was a high number, let's say it was really close to 0.15 and it was like not very rare at all, and I could get that sample, then I wouldn't be able to reject HO, and I would say fail to reject HO. Okay, I would fail to reject HO. And then I wouldn't have evidence to show that this is true. But since I am rejecting HO, since p-value is less than 5%, I reject HO and have evidence to show the infestation is less than claimed. So they were just trying to get my money. And I shouldn't give it to them. Okay, and that's a hypothesis test. Again, if the p-value was higher, let's say the p-value was like 10%, and there's still a 10% chance of getting my sample, then I couldn't prove that this is wrong. And so I would not have evidence to show that the infestation was lower than they claimed. And therefore, I might give them my money. Okay. If you have any questions or concerns, please email me, please remind me, and I will be here to help you. Good luck.